In this lesson, we'll apply the basic properties of logarithms. And I alluded to one of these in our last lesson, but let's go ahead and talk about them. The first one is if I have log base b of 1, I get 0. And of course, this is pretty intuitive since I take anything to the 0 power would be 1. So if this value is 1, we know that the solution is 0. This one also very intuitive. Log base b of b equals 1. So that means b to the first equals b. And of course, that's pretty straightforward. These two, you can think of them a couple of different ways. So the first way is, of course, to do our normal thing, which is b to the x equals b to the x. But what I end up finding is that if you have log base b and you have the b that you're taking the log of, that those things end up canceling out and you just get x for your solution. Okay, so again, if you have log base b and then you have b, then x is your solution, or whatever this value is up here. Same thing here. We can do the way that we did it before, which is b log base b of x equals log base b of x, which is what we've done all of this time. What I tend to think about is if you have a b and this is a log of that same base, again, this is my solution. So let's talk about how this can make life a little bit easier for us if we're trying to simplify logarithms. Here, 14 to the what equals 14. This is obviously 1. 10 to the what equals 10. Remember, if there's no number, that's the common log. So 10 to the what equals 10. So that's 10 to the first. This one, remember, if it's a natural log, the base is e. So it's saying e to the what equals e. So essentially, natural log and e, these things end up canceling out, and I just get 1. 144 to what power would be 1? That would be to the 0 power, because anything to the 0 power is 1. Here's one of those where I would just cancel out the log base 8 and the 8 and just get my solution of x. Again, you can do it the long way and say 8 to the what equals 8x. Natural log and e, again, just like above, these will cancel out, and so my result is 4x. Here, the log base 5 and the 5 are inverses and cancel, so that gives me 22. This is a 10 and a common log, which is, of course, base 10. Those cancel out, and I just get 3x. And then, again, log base x of x. Those have the same values, and so my solution is 2. Here are just a couple for you to try on your own, then press play to check your work. Again, simplifying, log base 4 of 4 should be 1 because 4 to the first is 4. Log base 10 of 10, those things cancel, and I just get e. Pi to what power is 1? Anything to the 0 power is 1. Natural log and e, automatically you should think those are canceling, so that's 4x. E to the natural log is base e, so again those cancel and I just get 4. And then a, log base a, those things are inverses, they cancel each other out, so it's 198.